The delete operator can do one of two things. And firstly, most obviously, it will kill any particles that flow into it and meet this criteria. In some respects, it can be thought of as a test with no output wire. In other words, if a particle answers true to its test, then it's not going to go anywhere. Now, let's show how this operator works by linking it up with the flow that we can see here, and seeing how it interacts with the particles. Now, currently, if I move this over here and I scrub through the animation, you can see the particles are actually flying out off into the distance. So there's nothing really very unusual there. So what I'm going to do now is I'm actually going to link up this event with this event, and we'll see what happens when we pop the particles into this delete operator. So in this case, I'm going to use an age test. I'll just pop it on the bottom of here, and I'm going to keep the age test very simple. I'm just going to set it to 5 frames, and when all the particles are older than 5 frames, they'll be sent to this new event. So there they go into this new event. Now, if we have a look at the operator, you can see it has 3 different options, and then we have 2 different parameters which can be used with some of those options. And below we have the uniqueness parameters, as I've just discussed. And again, they're used for any sort of randomized values. As you can see here, we're using variation. That's a randomized value, and that uses the uniqueness seed to randomize itself. Now, in this case, we're actually deleting the particles based on their age, and we're using a random range here. So the first thing I'm going to do is I'm going to get rid of the random element and get rid of any variation. Just pop that to 0. And you can see now that what should happen is the particles should reach an age of 5. Then they get passed into this event, and then they get checked to see if they're age 30. And when they're age 30, they pass true for the test, and boom, they're deleted. So let's have a look at that. There's the particles, they're birthed, they fly out, and they disappear. Now, if we have a look at the birth operator, you can see that I'm actually emitting starting on frame 0, and I'm stopping on frame 0. So all the particles are emitted on the same frame, which means that they'll all die on the same frame as well. So that's pretty clear cut here. There we go. Now, a way of getting rid of this obvious pop-off where the particles disappear all in the same frame is to change the birth rate. So you can actually say, let's stop emitting on frame 30, which will give us a nice range in our particle ages. So as the particles get emitted, they fly out, and then they all die off in a much more gradual way. And this is because they've all got different ages, so they all answer true to the age test at a different time. If we put that back to 0, the other way we can actually randomize the death point is to actually use the variance value here. So I'll change this to quite a big value, and this is a plus and minus value as it is with most of the other particle flow operators. So you've got to think of it like this. The lifespan is 30 minus 29, or possibly plus 29. So that will give us a range of between 1 and 59 frames. So particles can die when they're actually 1 frame old, or they can die when they're 59 frames old. And anywhere in between that. That's the actual random range that I've actually put in there. Now, something to bear in mind is that that's actually not quite true, because they actually only ever enter this event after frame 5. So in some cases, when particles enter this event, they'll be killed immediately because they've already been chosen to die by this random value here. So if we scrub now, you can see that the particles fly out, and they die off in a much more random manner. So you can see you have some options there in the way that the particles are killed off. And as I said, you can actually change the random seed, and that will change the random values used for deciding the death point of the particles. Now, the other option that you have is to only kill selected particles. So I'll just turn that on, and you can see immediately half the particles disappear. Now, that's because I've actually been a little bit sneaky, and beforehand I've gone into the particles and selected all of these particles here, which you can't currently see because they're deleted. So I'll just turn off this operator, and you can see there are our selected particles. So, you know, you can make any kind of selection of particles that you want, I'll just do a stripe through the middle here. We'll leave go of that. And now, if I turn that back on, you can see just the particles in that particular stripe are killed off. So you've got very, very specific options there. You can actually slip this operator into an event where you have a rogue particle. That can happen very often when you're working with a director, and the director will say to you, you know, I want this snow to fall on our character in our scene, and then he'll say, you know, something very specific, like this particular flake lands on the character's nose and it looks silly, so he'll want you to delete that particular snowflake. So this particular option is perfect for that circumstance. Just select that option, pop a delete operator into that event, turn on selected particles only, and it'll just delete that particular particle or any other problem particles that you may have. So that's a very useful feature. Now the last option, although I'm actually running through these backwards, you could say, is to kill all particles. So we'll just turn that on, and what will happen now is when the particles reach age 5, they go to this event and they're all killed. So there we go. It's a pretty sudden end to their lives. Not really worth them getting out of bed this particular morning, was it? Now that's actually useful sometimes because, you know, you just want to kill particles off. It's as simple as that, and you can use a test and then you can pass them to another event and those particles don't exist anymore. It's as simple as that. You don't want to decide on a duration. You're not interested in you know, what's the age of the particle or whether it's selected. You simply want to remove it from the scene. So you can use this option to very quickly remove particles. Now if I take this operator and pop it into the first event, that particular option isn't really very useful at the moment because, you know, we're having our particles born, and, you know, we then set up their position, and then we set up their speed, and then we display them as ticks, and then we kill them before they get to do anything. So you can see we've got nothing going on here. If I turn that to selected particles, we've just got our particles here, and, you know, I can turn to particles by age, and we've got the same test again. So as the particles fly out, they're actually, you know, exceeding the age of this particular animation range. So we're not really getting that much noticeable effect out of it here. So there you go. That's the delete operator. It's an odd bedmate really in this particular set because obviously we've got two birth operators and a delete operator. But you can see, you know, both set types of operator are very, very key in particle flow. You know, birthing particles and deleting particles are fundamental to working with particle flow. So they're operators that you'll be using constantly. Now, the other thing that I haven't really hit on here with deleting particles is that without deleting the particles, you have no concept in the particles of their age. Effectively, they're immortal. The particles will just keep on flying forever and ever and ever and ever and ever. Now, that actually turns out to be a bit of a problem with some of the features of particle flow. As an example, there is a particle flow bitmap, and that bases itself on particles age. And there's also a particle flow age map, and that actually will change color using a percentage of a particle's age. Now, if a particle doesn't have an age value, then that particular age map isn't really going to work. So if you're using the age map in your materials and you want it to work with your particles, you have to ensure that the delete operator is actually in the event that you want that particular map to work with. And if you're using Afterburn, which is a volumetric rendering system, you have the same thing going on there. A lot of the parameters in Afterburn can be controlled by particle age. And again, if particles are never going to die, they don't have a real age. So again, it's useful to assign a delete operator to any event where you want particles to have a definite age span that they will actually live over. Otherwise, these particular features won't work. So that's it for the birth operators. That's it for the delete operators. Let's move on to the transform operators.